Hi everyone, welcome back to the channel. And today I solve Leetcode daily challenge, problem number 201, bitwise and of number range. So it is a medium level problem, and I just have to find the trick to solve this one because the range of left and right is very big. So we'll look into the trick which we can use. So we'll first check out the problem statement, then we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that given two integers left and right that represents the range left and right, so it will be inclusive of these two values. Return the bitwise and of all numbers in the range inclusive, sorry. So there are multiple approaches to solve this question, like for example, you can iterate all the numbers one by one and get the bitwise and results for the solution. But if you come to the constraint and you see the range, then the number which we can get, it is quite large. So that won't be an efficient solution to solve this question. Rather, what we can do is let's check out the approach which you can use to solve this question. Okay. So for example, I took the first example from the problem statement where left was 5 and right is 7. Now, what if I find, okay, so let me, my left is 5, which can be donated with 101, and 7 is 111. Okay, so this is the binary representation of 5 and 7. What I want to do is I want to find out the same prefix or the common prefix between the lower end and the right end. For example, in this case, it is this one. Okay, so how you can what does this imply? So for example, if you'll write down uh, the binary representation of each number from, let's say, 0 to 9, let's try. Okay, 8 and 9. Okay, so it will be like 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1, and after that we'll have 7. Okay, 8. Okay, so if you observe this, you will find a pattern that with every, in every half, like this one, we are having the same prefixes. For example, if my number was from the left number was 4 and the right number was 7, what is the common prefix? 0 1. Okay, or you can just simply say 1. Okay. And if you write down the binary for further numbers, you will find the same relation, that this pattern will continue to follow. Okay, so now what I want to do is I want to find the common prefix between all the integers, and that we can do by simply just pulling the common prefix between the lowest number and the highest number. And how will we do that? So what we're going to do, we will check if these two binaries are equal or not. Okay, these two are equal or not. If they are equal, then we will say, okay, uh, we have found the common prefix. But if not, then what I'll do, I'll right shift my values. Okay, so now for example, we checked for, let's just do a dry run. Okay, we have 101, which is not equal to 111. Okay, I'll right shift by 1 bit, so now we'll have 10, which will be not equal, we are right shifting both the numbers, which is not equal to 11. Again, we'll do the right shift, so now we have 1, which will be equal to 1. So this is the common prefix, and if you see, this is a correct observation, right? But what does this imply? So we have shifted this 2 times, right? We have made 2 shifts. So to get the final answer, we will have to left shift the exact number of times which we have done to get to our answer. For example, if we have 1, we will shift it 2 times. So this will end up being 100, which is what? 4. Okay. So if you'll, let's say, sorry, 110. So if you do the bitwise AND for all these numbers, so you can, observe that you will get 4 only, because 10 will be 0, then 01 will again be 0. Here again 010, 010. But here all the numbers are 1, so that's why you are getting 1. And that is the same number which we got here. Let's check out the code for the same. Okay, so this is the code. I have handled one of the base conditions where if my left and right are same, then we can just simply return left. Also, I think if I can also write or left equals 0. I think in this case also we can just simply return 0. Okay, so what we are doing over here, we are running a while loop while my left is not equals to, I think I can write not equals to right, because this is what we see in the explanation, and we are keeping a track of the number of shifts we are making. So what we did, like we checked if left and right are equal. If not, what we are doing, we are shifting the numbers by 1 bit. Okay, and we are updating the shift counter by 1. Okay, and we'll keep on doing this until we get both the values same. Okay, now once we have the value same, what we will do, we will take the left value and will again right shift with the same number of times we have shifted to get the results. So let's check out the test cases. I just hope this condition doesn't mess up, because I didn't thoroughly tested this one. Let's see. Okay, so it is taking some time. Yeah, so the solution got accepted, and as you can see, like we have performed fairly well. We have outperformed around 86% of submitted solutions. So yeah, this was the solution, guys. Thanks again for watching out the video. Stay tuned with the paying ones. Don't forget to like the video and subscribe to the channel. Thank you.